Hi, thanks for checking out this channel and another one of our videos. We've got over 500 videos on YouTube as of December 2020. So if you got to make a brand and a model of a fence charger, you do a search on YouTube and you'll probably find one of our videos out there. We got all kinds of different kinds of videos of how to test things, fix things, review videos. We've also got videos on YouTube of cattle scales and low bars, and we do have some videos on like fence testers and stuff, how to change the batteries, how to reset them. Different brands you can do actually repairs on. Some brands you can't work on. But hit us up sometime. Look us up. There's our information right there. Fencerfixer.com. Phone number, call, text me, and address there to ship something to. All right. Well, this is going to be a how-to video on how to test and repair probably on this Gallagher MBX2500. This is a 110, 120 volt unit. I'm sure they made a 220, 240 volt unit elsewhere in different parts of the country. I think Canada sold a MBX 1500. Down here in the States, they never sold that version, but I have heard of it. Looks identical, different board and then different capacitors probably, but the rest of the unit's probably the same. So I was going to plug it in. I can hear something rolling around inside, but doesn't sound nothing big inside that's rolling around, but we're gonna plug it in here, see what it does. Ooh, lights up. Ooh, E3. Okay, E3 has an error code. Now these error codes are pretty generic. I mean, there's not much we can do with error codes. Basically, if you look at well, you probably don't have it, but in the technical manual on this thing, like E2 to E7, basically it means that it's detected a failure within itself. Basically what it says. It doesn't tell you what the failure is or what's caused it. There's monitoring software and things, and it always keeping tabs on itself inside, and when whatever is causing that thing goes bad, it throws an error code. There's other errors that can pop up there, but this says E3. So there is something small rolling around, so I don't know, a piece of plastic or a piece of dirt or what it is. But we'll take the screws out of this thing. I think this one is it's a plug-in or battery unit. That screws doesn't spin. That one spun out. That's good. That one. But they don't have safety screws in this one. Ooh, that didn't sound good. It's like the plastic cracked on that one. But this is an older unit. They don't make it anymore. They make most of the parts for it. But this particular unit, if you look at the back of your unit, look, the G302404, that's the product code for the whole entire unit. But look at that long number there. Sometimes the stickers are laying this way, so you have to turn it like that, look at it. But this is an earlier version. Look at the serial number. Look at the first two digits of this long number here. The first two is the year it was built. So this unit was built in 2003. The third and fourth number is a week. Fifth number is the day. So this is built on the second day of the third week of 2003. That's when this unit was built. I don't know when he bought it, but that's when it was built. So 17 years old. Oh, damn. Come on. Oh, those screws are loose. Ooh. I like the sound of that. I don't like the look of that either, but God dang, come on. Alright, pull this back cover off. Alright, this has been worked on before because this has got a 2012 circuit board in it. Sticker there says 12393, so 12 is the year it was built. So this board was built in 2012, so this unit's been worked on once before. I'll unplug these two wires. This wire's for your 12 volt, because this unit can be run off a 12 volt battery. And this wire's ribbon cable type thing here. There's a display board underneath this board, and that's what that plugs into. Okay, I don't know what the hell was wrong. I know what it was. Part of it was the screw mount on the back case is broken. Just old plastic. First thing I want to do is I want to check these capacitors. These look to be the original ones, because Gallagher hadn't used Plessy Ducon capacitors since probably 2005. They went to some other brand. So these things have got a lot of age to them. And that could cause it not to work. I don't know if it would cause that error code, but we're going to check these capacitors out. Now, to test your capacitors, look at your meter and look for that yellow symbol right above my finger, not the white one, but the yellow one. That's the symbol for a capacitor. If your meter doesn't have that, it really can't test these type of capacitors correctly. And we use a Fluke 115. That's the meter that we use. These are a pulse grade capacitor. They are 30 microfarad 1200 volt DC is what they're rated for. There's never 1200 volts on these. There's probably 600 to 900 volts running across these capacitors, but they put a bit higher rated ones so that way you can handle the stress and have a little reserve power there. No polarity to it. 29.9, that one's good. That one's bad. Those two big ones are the same. This small one is 6 microfarad, 1200 volt. This is like an RFI type capacitor, what they use in this spot here. I believe this one is for. It's kind of and these are actually, the small ones actually cost a little bit more than the big ones do, just because of what they're used for inside for whatever reason. 5.9, okay, 6. So this capacitor is bad. So let's we'll use these two. We'll put a new one of those in there, and maybe that's it. Maybe that's all that's wrong with it. Maybe it's one bad capacitor for the whole thing to fuck up. All right, here's a new capacitor. You can see it's 30 microfarad, 1200 volt. So we're going to plug that in. The little one goes right next to the transformer. That's probably the original transformer, because I think about 2010 or so they went to a different transformer design. It was the same shape, except it was kind of blue, see-through kind of case on it. The old ones were colored like that. They were green, reds, blues, dark blue, or kind of a not quite this color, but another shade. Of blue, black, I think was another color they used, green, like this one. Alright, plug this two cables back in. This one really doesn't matter for the 12 volt, but that one has to be plugged in in order for it to work. So, man, that'd be a nice cheap fix. It's an expensive unit to replace, $1,000+ for a new one. Alright. Still some shit running around inside, but it's probably the plastic off that stud, I would guess. But we're just plugging in, see what happens. All right, plug in the power strip, turn the power on. Hey, look at that. Bad capacitors solve the whole problem. All right, now what I want to do is I want to put a fence tester across terminals. This is a pretty slick unit. It's got 4 terminals on here. It's got a red and green for your fence and ground. It's got a black one right here, which if you zoom in here real quick. Alright, yep, and you can see it's labeled with the little lightning bolt there. So red's your hot, green's ground, the ground symbol. And you see this black one with like a reverse ground symbol, the little arrow, that's your ground reference. So it keeps tabs on your ground voltage. And then the blue is like your fence reference, so you can keep tabs on a certain section of fence. Most people never really used the black and the red, but it was there just in case. And if you look at the display here, it also has those 2 symbols. It has a ground symbol for this is for the black one, has that symbol there, which is for the blue one. And you can see these are both flashing 0 because they're probably turned off. I think they come from the factory with these 2 settings turned off. There's switches on the back of the unit. that you can turn off and disable, but I think they're disabled from the factory as a default setting. But basically what the blue and the black are used for is, these are pretty big units, up to 25 joules is what these things are rated for on their energy. And so it needs a pretty good ground system. So if you've, if for some reason if you had this black wire hooked up, you don't hook up to the ground system itself. You knock a separate ground rod about 8 feet, 10, I think it's 5 to 10 feet away, or 10 to 15 feet away, something like that. Knock a ground rod in the ground, tie it onto that, and that kind of electronically, through magnetic fields and all the magic stuff through the ground, will talk to and monitor the ground side of your ground system, but not, you don't want to physically tie into the ground system itself. I believe that's what the book says. And basically, it keeps tabs on your ground voltage, and if your ground voltage goes above a certain amount, and let me show you something too. If it goes above a certain amount, this number will climb up, and you can have different thresholds. If you look at the back of the case, there is these set of switches on here. There's oh, actually up inside here, a set of 8 dip switches and a set of 4. Looks like the set of 4, yeah, set of 8 looks like it does like the alarm stuff for your different alarms, like output alarm, fence alarm, earth alarm. You can disable it, enable it. Like your earth alarm, that's for that black terminal. You can see the default setting is disabled. See for your switches 1 and 2 on the set of 8. It's like the default setting is turned on, and it's that says if the voltage on your ground side is greater than 0.5, that alarm will go off. But that's on your earth alarm. You can also have remote control electrical interference switches, which it's on the set of 4, switches 3 and 4. It looks like it's set to the most sensitive, which because he did send the remote control with it. This did, when you bought this thing back in the day, it came with the remote control. Strictly a remote. It's not a fault finder remote. It's just to turn it on and off. See, a little light comes on. It came with this kind of a handy little tool. So if you were out in the back, the thing would run probably 1,000 acres or something like that. So if you're in the far back corner of a big area and it you find a problem, instead of running all the way back to unplug your charger and then drive all the way back out there with your problem, that you could take this with you, turn the energizer off into standby, fix your problem, turn it right back on without having to go back and forth or call somebody, hey, plug the charger back in and unplug it and all that stuff. So it came with this remote control. So the electrical interference thing on this, what that was all about was certain areas, depending on what's around you, airports, military base, cell phone towers, radio towers, stuff like that. There's a signal coming out off of those, and your electric fence is basically a big antenna, big magnet, whatever you want to call it, out there doing stuff. And this remote puts off a certain signal onto that wire, sends it back down the line to the fence charger. The fence charger sees that signal, and when it tells it, okay, turn into standby, so it goes into standby. Certain areas of the country, depending on where you're at and what's around you, they could accidentally go into standby on its own without even having the remote control hooked up, hooked on the fence. So that's what the remote control interference is for. So it's set to the most sensitive, so you can actually turn the sensitivity down by, there's some different combinations of switches. Up here it tells you the pattern for what switches need to be turned to what to do these different settings on certain switches. So let me see what he's got set at. So switches 3 and 4 on the set of 4, they're both up. So it's set to most sensitive, so we'll leave it alone. Earth alarm is switches 1 and 2 on the set of 8. And default setting is 1 down, 2 up, and he's got 1 down, 2 up, so that's still the same. So earth alarm's fine, or that's what he set it at. And then there's a remote control enable disable up here. It's switch number 2 on the set of 4, and it's switch Down is enable, which is a default setting, which it's set to down, which I would think it should be or would be. Switch is 1 on set of 4 is battery save, and it is set to default of battery save. So if you run it off a battery, if you run this off a 12 volt, it would as the battery gets drained down, it would slow down its pulse or shut off altogether. If you can have it to default, which means battery save, so it'll probably slow the pulse down, the battery starts getting low, or you can have it to normal speed, which means it's going to pulse the same. And as the battery gets lower, it's still going to pulse the same until the battery gets to a certain level, and then it's going to just shut off because the battery is going to be too low. So it switches. That's switch number 1 instead of 4, and it's up, and that's what he's got it set at already. The output alarm, which is your output voltage alarm. So if your voltage goes below a certain amount and stays there, the output alarm will go off, and that corresponds with that number right there, this kilovolt number right here. So if that voltage falls below a certain parameter, certain level, the output alarm will go off, and they've got it set at switch number, it's like 7 and 8 on a set of 8. The default setting is less than 3 kV, so when that voltage on there, when it gets dragged down below 3 kV and stays there for a few pulses, it has an alarm go off. And it switches to 7 and 8, and he's got it set to default, which is 3 kV, so it's set to where he left it at. Fence alarm, which is that blue terminal. It's like if you want to monitor a certain section of fence, like you don't care about the back 40, but you care about the front side where like maybe a main road runs, and you're like, well, I really need to keep tabs on that main road because I want to make sure that fence is always hot right there because I don't want the cows getting on the road and getting hit by a car and hurting somebody. So you could hook that blue wire up if you wanted to. From the factory, it's disabled, and switches 3 and 4 on the set of 8 is what that's for. And switches 3 and 4, he's got it set to up, so he's got it disabled. That's also why this number here was shown 0, because it's disabled. That's from the factory. They don't have that on because you may not need it. You may not be using this blue terminal. I mean, you may not have to, but it was there just in case. The only other switches on here that really mean anything is the very bottom one here. It switches 5 and 6 is for your remote control codes, which means that these remotes here, they have a set of switches on them, just 2 switches on them, a 1 and a 2, and basically either 2 up, 2 down, or 2 switches up, 2 switches down, or both down, both up, whatever. But whatever this is, this needs to match, or whatever this is, this needs to match. So default setting is switches 5 and 6 both up. That's what he's got it set at. So I would imagine that this remote is probably set the same as well. So if this remote is not the same switch pattern as switches 5 and 6 down here, this won't work. It won't talk to it. So let's just turn this thing over, plug it back in. We're going to I'll put my fence tester across it first, make sure we're putting out good voltage. And then we'll also do a remote control thing on here in a second, but we're going to put this tester on here and see what we read. Right now, it says it's reading 6.5. I don't know if that's right or not. Thought it'd be a little higher, but we'll see here in a minute. All right, we're going to put the tester across here. I don't know if you can see it or not. It might be a bad glare. This tester's not the greatest. Tester shows 10,000 volts. All right, well, whatever. 10,000, 6,000, still plenty of voltage. Let's take this remote control. So what this should do is all these little things here. I think one of these lights will probably turn red, I think, and it'll definitely stop clicking. And all these little screens will go to dashes if it works right. And like, say when you're out in the fence and you've got one of these testers or these remotes, when you hook it up, that little red light flashes with every pulse. So if you're out there on the fence and you find a problem, like, okay, I need to put my fence in standby. So you put the test remote on there, push the button, and you're way far away from the charger, so you'll never know if it's on or off. But see that light's not flashing anymore on there, right there. It's not flashing anymore. You know, when you're out in the fence, you're okay, well, the light's not functioning, so it must be in standby. So then, but this is what it looks like at the fence charger. This light turns red, and the display is showing all these little dashes. So it means it's in standby. So say you fix your problem, whatever the problem might be. So if you're out there on the fence, you're okay, I fixed my problem, broken wire, whatever. Put your tester back on the fence, hit that button again, you're like, you wait a second. Oh, look, my light's flashing again. Okay, my fence is back on. So pretty handy little tool. I love this thing. It works really good. It only works with older style Gallaghers. It only works with like 5 units altogether here in the States anyways. It worked on the old style from like the 80s and 90s, the MBX2500 and MX5000. And then later on, the early 2000s, it worked on the MR units, the MR2500, MR5000, and then of course this MBX2500. It won't work with any other model than those 5. In Canada, of course, it works in the MBX1500. So another quick cool thing about these Gallaghers, the reason why they seem to go for a long time, is this unit is an adaptive control unit. So if you look there, it tells you how many joules. It's putting out right now, it's using 7 joules of energy right now. We're going to take this load here. This is a big resistor. It's a 20 watt, 150 ohm resistor. And I'm going to put it across the green and the red. And watch, this unit will adapt its output to the load it feels, whether it's a small fence or a big fence or a heavy loaded fence or not so heavy loaded fence. It will adjust its number on the fly. It'll gradually climb the, what will happen is the voltage will drop for a second, and then as the joules climb up, voltage will climb up, and then it will stabilize somewhere. So I'm going to go across here. See, the voltage fell down to 1.9, slowly climbing up. We've got it maxed out 25 joules at 3.3 kV. So that's a pretty heavy load. Take the load away, kind of stabilizes and resets itself. So now it's back down to 5. It probably kind of like 6, 7 joules, somewhere in that range. So, but these are pretty slick units. I mean, they were really handy. Ahead of their time when this unit came out. Nothing really out there was doing the same thing as this one was, especially the adaptive control stuff. It's pretty slick on Gallagher's part of what they were doing. But units seem to be working fine. I'm going to check the voltage on my spec sheet on it in front of me. Check that voltage there, make sure that that's right. But 150 ohm load's pretty hard on a unit. I mean, it's pretty heavy load. Let's see what kind of spark this thing jumps just for the heck of it. Pretty hard hitting unit. Alright, well that's about it basically for this video. So we're going to call the customer up and tell them we got a cheap fix for a big charger. And get this guy squared away. But this is a nice cheap fix for a $1,000, $1,500 charger. So, alright, well hopefully this helps you out. Got any questions, give us a holler. Send a unit to us for repair. We'll be happy to look at it for you. Free quotes. No matter what brand or age it is, we'll work on it for you. So until next time, we'll see you guys later on.